So let's go over this graph analysis worksheet. This is a great worksheet to really become more comfortable with graphs and what these lines or curves are really trying to tell us. So we'll start with the first one, graph A. What matches which description? So in graph A we have time and distance, and so it's a straight line. So what is it showing us? Is it showing us acceleration, constant speed at a low rate, negative speed, no motion, etc. So here we can know that it's showing us no motion. So basically that's because in the graph, as time passes, the distance stays the same. So for graph A, this is showing us no motion. Graph B, if we look at the descriptions here, it's a straight line, so we know that the speed is constant. So we definitely know that it's number 2, 3. It could be number 6, but since it's a positive slope, we know it's definitely 2 or 3. Now, the other graph here that has a positive slope and it's a straight line is F. Now, between B and F, we can tell that the slope of line B is greater than the slope of F. So immediately we know that it's constant speed. It's a constant speed. So because it's a straight line, but we know it's a high rate of speed because the slope is higher than the slope, or is larger than the slope of graph F. And remember, in a distance versus time graph, the slope represents our speed. So the slope of the line gives us information about the speed. So going back, graph B matches description 2. And again, it's because the higher the slope, the greater the speed. So we immediately know that graph F is number 3. So we can fill that in already over here. Going back, graph C, we said this before, it's a constant speed because it's a straight line, but we're moving backwards. So what does this mean exactly? Is that you started at a certain distance away from your reference point and you're moving back towards your reference point. So you're moving backwards. And if you remember from the gizmo, it showed that very well when it had the runner moving back towards the start line. So for graph C, we could match it to number 6. Graph D and E. Graph D, because it's not a straight line, and this is one of the graphs that we saw, because it's not a straight line, we know that the speed is not constant. Now, if the speed is not constant, that means the car or whatever this represents that is in motion, the speed is changing. So if the speed changes, we said that we define that as acceleration. So in this case, because the line is a curve, the speed is not constant. So I will write it here, speed, technical difficulties here. Speed is not constant. Okay, so therefore we know that there's acceleration. So for graph D, our description is 1. Now, for graph E, same idea. It's a curve, so we know that the speed is not constant. Now, we're left with number 4, and why would this represent a negative acceleration? Now what we could do is we can kind of split the curve up into parts. Okay, and we can think of the slope of the curve still tells us information about the speed. So if we look at the slope, if we divide the line up in two, for example, okay, so which here we can tell that the slope here is greater than the slope here. So if the slope here is greater, that means the speed here was greater, and then the speed in the second part of the graph was lower. So we know that if the speed is greater here and then the speed lowers in the second part of the graph, then we know that the vehicle or whatever, again, this represents, is decelerating. So for graph E, we have negative acceleration, which is number 4. Let's move next page. Same exercise, but this time we're looking at time and speed. And so remember, when we're looking at speed versus time graphs, the slope of these graphs gives us information about the acceleration. So let's look at graph A. So graph A, basically, if this is our speed, and it's as time changes, as time increases, or as time passes, speed is not changing, then we know that we have a constant speed. So that's number 2. For graph B, we have a straight line with a positive slope, so as time passes, speed increases, so we could immediately match it. We could immediately match it with number 3. So number 3, there's an acceleration. Now, of course, we know that there's an acceleration because the speed increases as time passes. However, we do know that the acceleration in this case is constant, okay, because it's a straight line. So because it's a straight line, yes, the speed is increasing, so it's accelerating, but acceleration is constant. The rate is constant, in other words. For graph C, same thing, straight line, but we have a negative slope now. So here immediately we know that it's number 4. So it's, again, acceleration is constant because it's a straight line. However, because it's decreasing from left to right, we have a negative acceleration. Last but not least, graph number D is basically 1. There's no motion because our graph is down here, and I don't know if you saw it clearly in your photocopies because it's probably black and white, but you can kind of see the blue line down here. So as time passes, speed is at 0, so there's no motion. Now if we quickly move to this graph here, basically tells us which one won the race. Well, we know it was Albert. And the reason for this is because Albert, like the other boys, like Bob and Charlie, all reached the 100-meter mark. However, Albert did it in the least amount of time. Okay, which runner stopped for a break? Well, we can see here that Charlie stopped for a break. And we can see that because as time passes, his distance is not changing. And how long was the stop? Well, it was between about 8 and 13, so maybe about 5 seconds. I believe this is seconds. Okay, calculate each racer's average speed. So you would basically just take distance divided by the time. Okay, so Albert run 100 in about 12 seconds. So in these cases, you would do, for Albert, now I'm running out of space here, so, and I'm sure you guys figured this out. So for Albert, we would do 100 divided by 12. For Bob, we would do 100 meters divided by 14. And for Charlie, we would do 100 meters divided by about 16.5, I guess. Okay, and then you would see that the speed, Albert speed would be the highest. Now this is a great worksheet. Again, I'm going to tell you, a great worksheet to really practice your graphs and what information to be able to get from your graphs. There's a blank sheet like this on Moodle under the physics tab. So go ahead and print another copy, a blank copy, and then you could look at it and study from that as well. Okay, thank you.